All right, welcome all you online learners. What we're going to do today is talk about how to divide polynomials by x. All right, we're going to be going over 4 different assignments, so just kind of keep watching. We're going to go over different ones. So this is going to be kind of the easy one to start out with. All right, so if I have this polynomial right here, all right, this binomial, and I'm dividing it by x, our answers should be a polynomial. All right, so what does poly mean? More than, basically more than 2, all right, 2 or more. So right now we have a binomial divided by just a monomial. So here's what I want you to do. I want you to write x cubed over x minus 5x squared over x. Now, if you've forgotten your quotient rule for exponents, even though you can't see it, that's a 1 there. All right, so what does x cubed actually mean? It means x times x times x, and if you're dividing it by an x, one of those gets canceled out, and you're left with an x squared. So basically, what's the quotient rule? Basically, you just take these exponents and subtract them. So 3 minus 1 is 2. Over here, all right, we have a 5, but you got 2, you got an x times an x, and that's being divided by an x, so these cancel out, and you're just left with an x. So this is going to be that's going to be my answer. All right, and just remember the quotient rule. If I have any variable that has the same base, and I have an exponent, all right, you're always allowed to take those exponents and subtract them. That's called the, I'll spell it as long as I say it, I'll spell it. It's called the quotient rule because it rules. So quick little review. Ready? If I said b to the power of 7 over b to the power of 9, you could say that's b to the power of 7 minus 9, which equals b to the power of negative 2, which is the same as 1 over b squared, just so you know. So if I had something easier like b to the power of 10 over b to the power of 3, that would be b to the power of 10 minus 3, which would equal b to the power of 7. So there's a quick little review of your quotient rule. Okay, so all I'm going to do right now is I'm going to take this, I'm going to type it in right there, nice and neat, so you know what I'm saying is true. X squared minus 5x. Let's see if we got it right. Sweet, we did. Okay, let's do this next one. Okay, well, you can do a couple of these. You think you pretty much get the concept if I just do a couple. So we have 3x to the power of 5, okay, minus an x, all right, all over x. So if I'm dividing everything by an x, that basically means I'm dividing this by an x, and I'm dividing this by an x. So that's x to the power of 1, that's x to the power of 1, that's x to the power of 1. So it's kind of cool. You can hopefully see a concept here. X to the power of 1 minus 1 is x to the power of 0. Well, hopefully you know x to the power of 0 is 1. Any number to the power of 0 is 1. So these totally just cancel each other out. X divided by x equals a 1, as long as x doesn't equal 0, technically, because you can't do 0 divided by 0. So what does that mean for us? That means these cancel and you just have minus 1. Here you have 3x to the power of 5 divided by an x. So basically what's 5 minus 1? 4. So put x to the power of 4. So we get 3x to the power of 4 minus 1. So I'll write that right here. 3x to the power of 4, and I'm going to do minus 1, just like that. Okay, and woohoo, I'm done. Yay me. All right, now we're going to go over here to dividing with remainders. What? How do I divide with remainders? So here's a little hint. It gives you a hint. See here? It says your answer should be in the form of p of x plus k over x, where p is a polynomial and k is an integer. Like, what the heck does that mean? We're going to show you. This makes it really easy. So we got 4x cubed. That's being divided by x. I got minus 3x. That's being divided by x. And then I got plus 1. That's being divided by x. This I can simplify. Okay, because 3 minus 1 is 2. So I got 4x squared minus. These x's completely cancel to a 1, so I'm left with minus 3. And then I got plus 1 over x. And that's my answer. That's my answer with a remainder. I'm going to literally type that in exactly. Now, wait a second. What is the p-value? Let me show you. Ready? See that p of x right there? That part is this part right here. That's the polynomial. Well, technically it's a binomial, but a binomial is a polynomial. And then right here, where it says k is an integer, 1 is an integer. So technically that's the second part that I'm going to write. So here we go. See if I can write it nice and neat. I've got a 4, I've got an x, and that's being squared. I'm going to put minus 3. Okay, minus 3. And then I'm going to put plus, I'm going to make a little fraction here. Put 1 over x just like so. Press check. Boom, got it. Let's do one more. Here we go. You can write it down. By the way, if you're just watching me do this, it's really not going to help you, but you can write it down and it probably help you more. 6x to the power of 5 divided by what? Divided by an x minus 2x to the power of 4, all being divided by an x minus 1, all being divided by an x. So what I'm doing right here, I'm showing you how to take this this expression and being able to break it down so you can do it one by one. So just remember, this is x to the power of what? X to the power of 1. All right. So 5 minus 1 is 4, so that leaves me with 6x to the power of 4 minus 4 minus 1 is 3, so minus 2x cubed. And then I'm just what? Minus 1 over x, and that's going to be my final answer. It's not a very good 4. I'll rewrite it nicer and neater. Here we go. 6x to the power of, come on, man, you can write a better 4 than that. There we go. So that's my answer that I'm going to put. That's the form that it wants me to put it in. So here we go. 6x to the power 4. Then we got minus 2x cubed, so to the power of 3. Then I'm going to put minus 1 over x. Minus 1, oh, I'll make that little fraction. Minus 1 over x. All right, so all I'm doing is putting this into that box. Okay? All right, we're done with that one. So what was this one? That was dividing polynomials, and this time we had a remainder. All right, on this one we didn't have a remainder. Okay, so we're done with that. So I'm going to close these out. Boom. Close that out. Now we get to have some fun. I like these. All right, it says divide quadratics by linear expressions but no remainders. This is where we get to practice our factoring skills. Makes it very, very, very easy. Okay? So on this one, there's not going to be any remainders. It's going to be nice and neat, but you have to know how to factor the numerator because it's being divided by this binomial known as x plus 2. So how do we factor this? Well, what you're looking for two numbers that add together to equal 7, but those same two numbers multiplied together equal 10. So you always start with the factors. I'm going to put a little thing. Always start with factors. Start with the factors. So what are the factors of 10? The only factors of 10 are 10 times 1 and 5 times 2. And of those factors, only 5 and a 2 can get me to a 7 and be multiplied to a 10. So I know it's going to be 5 plus 2 equals 7, and 5 times 2 equals 10. So I'm going to put x plus 5 and x plus 2. Interesting. These factors are the same. If the factors are the same, then they literally cancel each other out. And what do I have left? X plus 5. Is it that easy? No way. It can't be that easy. Oh, yes. Yes, it can. Now I'm going to see a step-by-step solution. Let's see what they do, just out of curiosity. What do? They factor it. What? They did the exact same thing I did? Now, the only thing they didn't do is they didn't show you how to factor. Okay, so understand, you're looking for two numbers that multiply to this guy, and then two numbers that add to this guy. Two numbers that multiply to this guy, two numbers that add to this guy. There you go. All right, let's go on to the next one. What? I see a difference of squares. All right, that's one of my curses. When I see binomials, sometimes I see a difference of squares. By the way, I'm referring to a movie, just so you know. It's called The Sixth Sense. Except he didn't see a difference of squares. He just saw dead people. All right, so what is a difference of squares? So ready? I'm going to show you what a difference of squares is, okay? A minus B, all right, times A plus B equals A squared minus B squared. This is called a difference of squares. It's so common. I mean, I see it on the SAT, ACT, TSI. I see it on all those standardized tests. You got to know what a difference of squares is. So I'm going to give you a few examples of a difference of squares just so you can see it. Ready? So if I said x squared minus 4, that would factor to x plus 2 and x minus 2. If I had x squared minus, let's say, 16, that would factor to x plus 4 and x minus 4. If I saw x squared minus, I don't know, let's say 36, that would be x plus 6 and x minus 6. No, they're not all even numbers, okay? It's just so you know. So if I said x squared minus 81, that would factor to x plus 9 and x minus, nope, not 6, bro, 9. There we go. So these are all examples of difference of squares. So I know this is going to factor right here, 2 and x plus 6 and an x minus 6. What cancels? What cancels? X minus 6, man. Boom, boom. What's my final answer? X plus 6. Perfect. Put x plus 6 right there. Boom. Got that done. Okay. All right. Now we're finally we get to a slightly more difficult one where we get to do some long division. It's going to be exciting. We're going to do long division and we're going to do synthetic division for these two. Okay. All right, finally, we get to do something that's a little bit more difficult, which is divide quadratics by linear expressions, and we got remainders to deal with. All right, now we're going to do this. We're going to do this the synthetic division way because it's a little bit faster than doing long division. All right, so we're going to do synthetic division. So this is kind of how I do it. If you don't like it, well, you know what? Just look at a textbook and figure it out on your own. All right. What? I know, but people aren't going to watch this anyway. So, by the way, do you guys see this x minus 1 right here? Right? What number am I going to put right here? I'm going to put a 1, okay? If this doesn't make any sense, go back a video and watch the synthetic division video. It'll make a lot more sense, okay? Now we're going to list x squared, x to the power of 1, x to the power of 0, all right? So check this out. How many x squareds do I have right here? How many x squareds? By the way, class, now that you're kind of with me right now, you can answer this. Yes, there's 1. Very good. Do you guys see any x's up here? Nope, so I'm going to put 0. And how many constants do we have at the end? We have 2, right? There we go. So that's what I want you to write down. All right, so the very first thing we do is what? We drop this 1 down, correct? Drop down the 1. What do we do with these? We multiply them together. 1 times 1 is 1. What do we always do with these? We always add them together. 0 plus 1 is 1. 1 times 1 is still 1. And when we add these together, we get a what? A 3. Now 3, that represents our remainder. Okay? So that's the number that I'm going to put right here. Did everybody see where the k is? That's the number I'm going to be putting up there. Now what does this represent? Right here. If that's x squared, this is what? X to the power of 1. So that's my x to the power of 1. And what does this represent? That's my x to the power of 0. So what's my final answer? X plus 1. So I'm interpreting this. This means x plus 1. And then what am I going to do? Plus 3. But what's the divisor? Our divisor was x minus 1. And that's what I'm going to type in to the Khan Academy. Now here's the good news. Everybody, every single problem that I've done on the Khan Academy, they give you the hint of what it's always going to be over in case you forget. You're like, oh, wait a second. What was I supposed to put it over? You're always supposed to put it over the what? Over the divisor. Okay? So let me go and type it in. All right, here we go. X plus 1. Then I'm going to put plus, make a little fraction. And what was our remainder, everybody? 3. And over here we're going to do what? X minus 1. All right, drum roll. Boom! Nailed it. Let's go on to the next one. Oh, I like it. Go and put this one in your journals. Okay? Don't worry. You'll be able to catch up with me because I'm going to write very, very slow. All right? So we have x squared minus 9x plus 14, and we are dividing that sucker, which is a polynomial. Technically, that's not a math term, but a polynomial, this sucker is not a math term. So we're dividing this trinomial by this binomial, but we're not going to do it the long division way. We're going to do it the synthetic division way. All right, so you know what? I'm going to make these lines a little bit neater and nicer, okay, just for this one. All right, is that okay with y'all? Good. If it wasn't, I wouldn't have cared. So, what number am I going to put right here in the chair? 5. Like, wait a second, how do you get that? What do we always do? We always figure out what number you'd have to plug it in to make it equal to a what? 0, right? That's what we're doing. Okay, so now we're going to list them. Ready? We already have one student yawning, falling asleep. Hopefully we'll kind of reduce that, okay? You're feeling very, very sleepy. Just kidding. You're not. Stay awake. All right. So now, how many x squareds do I have, everybody? 1. X to the power of 1. -9. Very good. And x to the power of 0. Boom. There we go. We got it all set up. Hopefully you're all caught up with me. Everybody all caught up with me? We good? All right. So what's my first step, everybody? Drop the what? Drop the 1 down. 5 times 1 is 5. Awesome. What are we always going to do with these? Add them together. -9 plus 5 is -4. I tell you what, when you're doing synthetic division, would you agree it's nice if you know how to add and subtract integers really quickly without having a calculator? It just makes it so much easier. I'm so glad I know how to do that. Okay, so 5 times -4 is -20. And then we add that. So if you owed somebody $20, but you only paid them back $14, you still owe them what? $6. Now, what does this 1 represent? That's your x to the power of 1. What does the -4 represent? X to the power of 0. What does that represent? That represents your remainder. So where are we going to stick that guy? We're going to stick him right here. So you know what? I am going to actually write it a little bit differently. I'm not going to put plus a negative, okay? I'm not going to put plus a -6. I'm just going to change that to a minus and then put a 6, okay? So here's my final answer that I'm going to write, and we'll see if it works. It should work because it's right. So what do we have? X to the power of 1. We have one of those, right? Our constant is -4, okay? And then what are we going to do? Instead of putting plus a negative, I'm just going to put minus. And what number am I going to put in the numerator? A 6. And what am I going to put in the denominator? X minus 5. And that's my answer that I'm going to put right there. Alrighty? So here we go. Let's see if this works. X minus 4. But what did I say I was going to do? I was going to put minus the fraction, and I'm going to put a 6 over x minus 5. Now, could I have done this? Could I have gone here and taken that away and put a plus, but then what do I have to put up here? So instead of putting plus a -6, what did I do? I'm just going to put a minus. So that's why I wanted to kind of do it in the video so you could see the difference. So those were technically the same answer, okay? Okay, let's see what they did, okay? Just out of curiosity. All right, so you guys see what they did? They still did what? X minus 4 minus a 6 over x minus 5, okay? Whoa, what did they not do? They did what? Long division. What did we do? Synthetic division. Do you guys see the difference between long division and synthetic division? Which one do you think takes longer? Long division takes longer. Now, this will, remember, synthetic division only works if we have what? We're testing a linear factor. Okay? And that's it. You guys go ahead, start working hard, get these done. It's awesome. Have a good day.